Welcome back, class. Today we are going to review comparing and ordering decimals field day style. Remember when we talked about when we have field day and we have a referee, and for us to race a fourth grader to race a kindergarten wouldn't be fair. We have more experience, our legs are longer, our heart is probably stronger. When we're comparing and ordering decimals, we are the referee, and we have to determine whether or not all of the participants are running a fair race. So let's start just by comparing two decimals and using the field day style idea to see if we could determine whether or not the participants or the runners are running a fair race and then determine the greatest one from that. Let's start with two decimals. Okay, let's start with the decimals 3 and 25 hundredths and 6 and 25 hundredths. Well, first of all, we have to make sure that this is a fair race. I see that there is a decimal in both numbers. There's a whole number at the beginning or in front of each decimal, and that there are two digits behind the decimal. If the whole number is larger than the other one, if one whole number is larger than the other one, we do not have to look at the numbers behind the decimal. In this case, 6, the whole number 6 is greater than 3. So our comparison symbol would look like this, and we would read this: 3 and 25 hundredths is less than 6 and 25 hundredths. This is where we got confused. This symbol turned to the right is read less than. Just like decimals have a name and commas have a name, the comparison symbols also have a name. We call them something. Just like reading a number from left to right, that symbol has a name and we call it less than. Now let's look at two more decimals. Okay, now let's look at these two fractions. We have 4 and 16 hundredths and 4 and 26 hundredths. Now this one also has 3 digits. Both numbers also have a decimal, but the whole numbers are the same. This is where we start talking about, is this race fair? If the whole numbers are the same, then we look at the digits behind the decimal. Well, this one has 2 digits behind the decimal, and this one has 2 digits behind the decimal. Since both numbers have 2 digits behind the decimal, we are going to consider this a fair race. Now all we have to look at is determine which one is greater. 4 is the same, decimal, decimal, 1 and 2. Well, I know that 2 is greater than 1, so I'm going to use the less than comparison symbol again. This sentence is read: 4 and 16 hundredths is less than 4 and 26 hundredths. Let's try another set of decimals. Okay, now we have two more decimals. This is where we get confused. Again, we are determining whether or not this race is fair. And in order to do that, we have to look at each part of the number. So here I see that both numbers have a whole number, both numbers have a decimal, and both have digits behind the decimal. The whole numbers are the same, which means the determining factor as to whether or not these two numbers are fair to compare lies behind the decimal. So here we have 1 digit behind the decimal, and here we have 2 digits behind the decimal. Well, this is not a fair race. Both numbers do not have 2 digits behind the decimal just by looking at it. However, we know with the magic of the 0, the superhero 0, that if we place a 0 at the end of a number as a seat saver, it can help us out as mathematicians. Now, both numbers have 2 digits behind the decimal, which means this is a fair race, and we can now compare them. So we're going to compare this using a comparison symbol. Again, we have a different symbol here. this symbol also has a name. We read this math sentence as 5 and 30 hundredths is greater than 5 and 4 hundredths. Now we could also say that 5 and 3 tenths, because this 0 was not here before, it's what we put there to help us to make the race fair. We could also say 5 and 3 tenths is greater than 5 and 4 hundredths. Let's try one more. Okay, we have two new decimals here. At first glance, this one looks bigger just by looking at it. But since we know that we have to make this a fair race because we're running a field day and all the participants have to have the same advantage. So we're going to look at these two numbers and decide how are we going to make this race fair. Well, I see that both numbers have a decimal and both numbers have a whole number that is absent. So if it's absent, we can say that there's a 0 there. That's just for us. It's not really there, but for us it's a superhero 0. It helps us understand that that is a placeholder. That in fact means there are no whole numbers. Now what I notice is behind this decimal there's only one digit. And behind this decimal is 2 digits. This is not a fair race. So we have to fix this so that it's fair enough for us to judge it and compare it to see which one is greater and which one is not. So I'm going to turn this, in order to make this a 2-digit number, just like this one, I'm going to add a 0 here. Now I see that this is 90 hundredths and 17 hundredths. Which means our comparison symbol is going to go that way. And we read that as 9 tenths is greater than 17 hundredths, or 90 hundredths is greater than 17 hundredths. Now that you understand how to make a race fair when comparing decimals, now let's do some racing where we have more than 2 participants. Okay, here we have 3 separate numbers. And I can see just by evaluating as a referee that each number has a whole number in front of the decimal and each number has 2 digits behind the decimal, which means all 3 of these participants or all 3 of these numbers are fair, and I can order them accordingly because they have the same amount of digits and have the same fairness. They are fair. They each have a decimal, a whole number, and 2 digits behind the decimal. So what we're going to do is, if I asked you to order this from greatest to least, we would pick 3 and 50 hundredths first. So I've put these in order. Oh, sorry. I put these in order from greatest to least, which has 3 and 50 hundredths is the greatest, and 99 hundredths is the least, and 1 and 2 hundredths is the middle number. Now we're going to order the same 3 numbers in order from least to greatest. And there you go. Now let's try 3 separate digits that we have to determine whether or not they're fair as a referee. Okay, I have 3 new numbers here. Now I can see that these numbers, these 3 participants, are not going to be fair. It's not going to be a fair race. This number and this number have a whole number in front of the decimal. This one does not. However, I know that that is a 0. It's a safe, it's a placeholder. I just do not see it. I can put a 0 there if I want, if it will help me, or I can leave it blank. Right now, I'm choosing to put the 0 there because I want you guys to understand that that means there's no holes. Now I'm going to check behind the decimal. This one has 1 digit. This one has 2 digits, and this one has 1. Now, I can't take anything away. I can add things to a number. I can add zeros to a number to help it, but I can't take a number away. I just can't take a number out. It doesn't work that way. So I'm going to use the magic of the superhero 0, and I'm going to add a 0 here. This makes it 2 digits behind the decimal, 1, 2. And a superhero 0 here also. This also makes 2 digits behind the decimal. Now our race is fair because each number has a whole number in front of the decimal, and each number has 2 digits after the decimal. Now I can arrange these in order from greatest to least and least to greatest. The only problem is when you rewrite them in order, You cannot use the magic super zeros that you used. We use those as a nickname, as a helper. It's not really what their name is right now. That's just for us. That's for us as a referee. So I'm going to write them in order without my superhero zero helpers. This is how they are written from greatest to least. We have 6 and 10, 1/10 is larger than 2 and 800ths, and the least number is 6/10. Now I'm going to arrange them from least to greatest. And there you go. We have 6/10 is the smallest number, at 6 and 1/10 is the greatest number. If you notice, when I rewrote them in order, I took away the superhero zero. Those are just for us. They're just for us to see that the numbers are fair, that they have the same amount of digits. It's just a helper. That's all it is. I hope that was helpful. Practice, practice, practice. And until then, happy math.